Hi, my name is Will Crandall, and today I will be presenting you my research fungal compounds isolated from the Underground Railroad tree inhibit methicillin-resistant Staphylococcus aureus, or MRSA. So I only have 5 minutes here to go over 7 months of research, so bear with me as I fly through this. So antimicrobial resistant infections are a very huge problem, and in the year 2050, the World Health Organization predicts 10 million deaths per year will be caused by these deadly infections, caused by deadly bacteria known as escape pathogens. That's because they escape the treatment of antibiotics. Among these are Staphylococcus aureus and the more clinically relevant methicillin-resistant Staphylococcus aureus. So currently, 70% of all drugs on the market are natural product derived. That is coming from plants, fungi, other living organisms. So natural products is a great way for drug discovery, and especially in combating these deadly pathogens. Finding new treatments and new antibiotics is a high priority, and fungi a very underutilized source. So this research project is super cool because fungi were isolated from the bark of a 300-plus-year-old tulip poplar tree. And this comes from the Guilford Forest, and this tree stood witness to events of the Underground Railroad and the runaway slaves being helped by the Quakers gain their freedom in the North. So this is a very cool historical background. So going over how I did my research, here's the method and instrumentation. I'm going to go over the experimental workflow in which the fungi were scaled up so that more extract could be obtained. The fungi were extracted, and I obtained 131.25 milligrams of extract of the most active fraction, which I'll get into a bit. I then separated this extract using liquid chromatography that separates the compounds based on polarity, and I isolated pure compound. To identify the structure of this compound, I use analytical techniques such as nuclear magnetic resonance, or NMR, and mass spectrometry. Using this, I could deduce the structure of the compound. As far as biological activity, we were able to culture bacteria in liquid medium and able to test our compounds and extracts at specific concentrations. So here I'm going to go through the biological activity data super quick. Basically, low error bars are good. That's y-axis is percent growth of bacteria. So the lower percent growth of bacteria, less bacteria is growing, meaning it's being killed. So here we're following up with the most active. The top are extracts, the bottom are fractions. And following up with the most active fraction, we further separate it using high-performance liquid chromatography on the left, and we have 1, 2, and 3 compounds. I followed up with compound 3, that peak you see there, because I had the most material of it. Using high-resolution mass spectrometry, we were able to predict a molecular formula of C27H36O6. Using proton NMR, shown on your left, we were able to compare this to current databases and literature. And figure 6 on the top right, you see 2 compounds. These are what I thought could be what I isolated. However, the proton NMR does not match. So using other prediction software, we are able to predict and propose a structure of a brand new compound that we isolated that inhibits the growth of MRSA, and that's shown on the bottom right. So that's the big takeaway here. In conclusion, a new compound was isolated from Xyleria species, and it was shown to kill or inhibit the growth of a deadly pathogen, that is MRSA. So this is very, very good news, and so in the future, further NMR studies will be done to confirm the structure of that compound. It's just a proposed structure. However, we know it is not known, so it is in fact a new structure. We'll test the other active fractions and follow up with further compound isolation and structural elucidation, and pure compounds can be tested for cytotoxicity, and currently working on writing up a paper about this. So thank you to Czech Lab and the research that I was able to do there, the university for allowing the instrumentation. Thank you to Oberle's lab for helping with structural elucidation, and thank you to URSCO for the funding. My name is Will Crandall, and this was my research project. Thank you for your attention.